Okay, so now we're going to use the stretch factor to sketch a graph of this function they're giving us, and then we're going to state the domain, range, and the asymptote. Okay, so I'm going to look at the parent function right here, and I'm going to call that g of x, like we did in another video, so 1/2 to the power of x. Now I'm going to make a table of values, x, and eventually we have to get f of x, the output. But g of x, I'm going to go ahead and put that in here. Now, I'm going to be choosing the points -2, -1, 0, and 1. The reason I'm going to use those numbers is because I have that fraction in there. My b is less than 1. So I know it's going to be a decreasing function, and so I can use a higher or a lower, a smaller negative number to get my values that I would like to get. So when I plug in -2 into g of x, so g of -2, that's going to wind up being 1/2 to the power of -2, which is going to be 2 squared, which is going to be 4. And then you can do that for all of these, but when I put in -1, I'm going to get 2. When I put in 0, I'll get 1. And when I put in 1, I'll get 1/2. Now my stretch factor is 4. So I'm going to be multiplying all those outputs I got for g of x. I want to multiply them all by 4. So this is going to be a 16, this is going to be an 8, this is going to be a 4, and this is going to be 4 times 1/2, which is 2. Okay? So now I can graph these ordered pairs, x, f of x, and I'm going to have -2, 16, which is already off my graph paper, but -1, 8, 0, 4, and 1, 2. Okay, so -2, 16, which is going to be way up here someplace, probably a little higher than that. -1, 8, which is going to be right there. 0, 4, 1, 2, 3, 4, and then 1, 2. Now, my graph is going to be running asymptotic to the y-axis. It just has this kind of large stretch factor of 4. So that's what the graph looks like. The domain is all real numbers. The range is 0 to infinity. And then the horizontal asymptote is y equals 0.